For this question, the probability involve playing cards. So you will need some prior knowledge about the playing cards first. So the playing cards are you can easily get the stack this kind of cards from a bookstore or supermarket. Okay, so in one stack, we got 52 cards. Okay, but when you buy the stack, right, it actually comes with two joker. So when you buy the stack, it actually comes with two joker, so there will be 54 cards. Okay, but the main cards that we will be using will be the 52 cards. So you just take note. For this question, right, we are using 52 cards. So we don't include the joker. So some questions, they may include the joker. So in this case, if we don't include the joker, that means we got 52 possible cards. So what are the makeup for this 52 cards? So it will be what we'll call four streets. Okay, so it will be hearts, and it will be diamonds. The hearts and diamonds, right, are red in color. So the hearts and diamonds are red in color. So it's mentioned here. And the club and spades are black in color. So this is the clubs. I'm not very good at drawing this part. So this is the clubs, and then this is the spade. So they are black in color. So is the 52 cards are divided into these four suites. So you can think of it like four category. So these are the four category. So how it's being split up, right? It's being split like this. Okay, so in each suite, okay, so when we talk about the heart, the red hearts, there will be a 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then there will be something called JQK. So JQK are what we call the picture cards. Okay, so these are what we call the picture cards. So every suite, right, there will be 3 picture cards. Okay, so every suite, there will be 3 picture cards. Okay, so the same thing goes for the diamond. So when you go to the diamond deck, you will see a 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. Okay, so when you go to the spade clubs, okay, you are still getting the same thing. A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. Then when you go to the spade, same thing. A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. So there will be 4 cards of A's, 4 cards of 2's, 4 cards of 3. So this will be the makeup of the playing cards. So if you observe, right, you got 26 red color cards. So out of the 52, you got 26 red, and then you got 26 black. Okay. And then there are 12 picture cards here. This group are the picture cards. So altogether, there are 12 picture cards. So you will need this basic knowledge, then you can be answering the question. Okay, so you're going to pick one card, and then what is the probability that you got 4 of diamond? So what do we mean by 4 of diamond? That means it's the card that is a 4, and then there's a diamond. So there's only one such card. So it will be one out of 52. Okay. Then what is the probability that you will get a club? Okay, so for club, I got 13 club. Okay, so here, this deck is the club. So I got 13 clubs. So it will be 13 out of 52, which is 1/4. Red card, half of it are red. So write the actual probability, then you reduce it. Okay, so what is the probability that is not a heart? You can count the number of non-hearts. Okay, so one sweet is heart. The others are all non-hearts. So actually it's easier if you do a probability of a heart. So we got 13 possible hearts out of 52. So you will get a 3/4. So what is the chance that you get a black ace? So these two are black ace. So you got 2 chances out of 52. And what is the probability of a picture cards? We got 13 picture cards out of 52. I'm sorry, not 13, 12 picture cards. We got 12 picture cards out of 52. And you go and reduce the fraction. So that will be 3 out of 13. So that will be the probability that involve playing cards. So if you didn't know the makeup of the playing cards, it's not possible for you to do it. Okay, so there's a lot of the variety of probability. So if you jump on to example 5, it is another kind of probability that involves the angles. So it's something like throwing darts. Okay, so if a probability involves angles, then the base or the denominator will be based on the total angle. Total angle is 360. So this whole thing is 360. Okay, so your chances is dependent on the angle. The bigger the angle is, the bigger chance it is. So in this question, right, we got a circle divided into 4 sectors. It's like 4 sections. And we're going to choose a point. Okay, so find a point that you will be in region A. Okay, by right, if it's in region A, I got to be calculating the area. Okay, but the easier way out, right, will be probability that is in region A. If you look at region A, right, it got a very high chance because there's a lot. You can look at the area exposed. So the area exposed is also decided by the angle. So in this case, the probability that it will be in region A will be based on the angle. So it's 150 over a total of 360. Because you are choosing from the whole circle, which is like equivalent of 360. So the chance will be 5 over 12. Okay, the next probability that it will involve either region B. Region B is 90 degree. Region D, okay, so you didn't know the angle for the region D. So you need to calculate the angle first. So do a angle sum of angle sum at the angle at the point. So if you use angle at the point, you'll be able to calculate the angles. So you will get a 75. So this angle is a 75. So what's the chance that when you choose a point, you'll be either in region B or D? So the angle exposed for B will be 90 degree. The angle exposed for D will be 75. So it will be 90 degree plus 75 over 360. So the chances that you will be in region B is 90 degree out of a whole of 360. So region D will be 75 degree out of a whole region of 360. So from here you get 165 over 360, then you reduce it. So that will be the probability that involve angles.